Hello children, welcome to AIMS India's online classes. In today's class, from mathematics subject, factorization topic we are going to continue. So in our previous classes children, we have learned about factorization and different types. So factorization by grouping the terms. One minute. Factorization by taking common factor out and by grouping the terms that we have learned. And about factor theorem also we have learned children. Factor theorem we have completed. So next children, we have remainder theorem. Up to factor theorem we have completed children. Our next concept is remainder theorem. So here the remainder when a rational integral function f of x. Here we have a function. We have a function f of x. We have a function f of x. So function means no need to get confused children. It is just an equation. 3x square plus 4x plus 5. Like this, if we have a function, if this function f of x, if it is divided by x minus a, means if the equation is completely divided by x minus a, or if x minus a is the factor of f of x, so then remainder will be f of a. Actually, if it completely divides, remainder will be 0. If it does not completely divides, remainder will be some number that will be equal to f of a, some number or expression which will be equal to f of a. So if they give any equation, if you assume it as f of x, if this f of x is divided by x minus a, then f of a will be the remainder. F of a will be the remainder according to the remainder theorem. Means it's a reverse of factor theorem, which we have learnt already. It's a reverse of factor theorem. So we know that using division algorithm, suppose if f of x is the dividend, we are dividing it with x minus a. If the remainder is cube of x, if the quotient is cube of x, then if the remainder is r, then this whole thing according to division algorithm, as per division rule, it can be written as dividend. It can be written as dividend f of x equal to divisor x minus a into quotient cube of x, means equation which is in terms of x, we have named it as q of x, plus remainder r. This is the normal division rule, where this is the dividend, this is the divisor, this will be the quotient, r is the remainder. So now if we have to find whether for this f of a is remainder or not. So this is f of x. If you want to find f of a, this equation is defined in terms of x. If you want to find f of a, then in the place of x, we have to replace a. Wherever we find x, we have to replace it with a. Then we will get f of a value. Here x minus a is there, we will keep a minus a. Cube of x is there, we can keep cube of a plus r. So a minus a equal to 0 into cube of a. 0 into q of a will become 0. 0 plus r, we can simply write it as r. So f of a equals to r, means f of a equals to remainder. F of a equals to remainder. So hence the theorem is proved children. So according to remainder theorem, if any expression is divided by x minus a, so then f of a will be the remainder. Suppose if it is divided by x minus a, then f of a is the remainder. Suppose if it is divided by x plus a, then we have to take f of minus a. This we have learnt already according to factor theorem. If it is divided by x plus a, then f of minus a is the factor. If it is divided by ax plus b, then f of this plus b will come that side, minus b, a will come downside, minus b by a is the remainder. If it is divided by ax minus b, then f of minus b will become plus b into a will become by a. b by a is the remainder. So if x minus a is the factor, f of a is remainder. If x plus a is factor, f of minus a is remainder. If ax plus b is factor, f of minus b by a is factor. If ax minus b is factor, f of b by a is the factor. These four shortcuts you have to remember so that you can solve any problem. If you won't remember these four shortcuts, it will be difficult for you. You cannot solve the problems. Next one. Again, some more shortcuts are there, children. Suppose x plus 1. X plus 1 will be a factor of f of x if the sum of coefficients of even powers of x is equal to sum of coefficients of odd powers of x, which means suppose we have a expression like this: ax cube plus bx square plus cx plus dx. Cx means cx power 1 we can write, simply d means x power 0 we can write, equal to this is the expression. So here we have x cube term, x square term, x power 1 term, x power 0 term. Suppose this 3, 1. Here power 3 is there, which is odd number. Here power 1 is there, which is odd number. These coefficients are, this is a, this is c. Means a plus c. It is the sum of odd coefficients. Or x square and here 0 is there. These are even coefficients of even powers. So b and d. So b plus d. If a plus c equal to b plus d, means sum of coefficients of odd powers of variables equal to sum of coefficients of even powers of variables. So then we can directly tell x plus 1 is a factor. So actually for finding f of x, if x plus 1 is a factor or not, we have to find the value of f of minus 1. But instead of that, directly just by observing the sum of odd coefficients, sum of even coefficients, if they are equal, directly we can tell x plus 1 is a factor. So just one after another we have to add. First we have to take a, we have to leave this one, and we have to add c, we have to leave this one. Like this. If you add these two and these two, if the sum is equal, then x plus 1 is a factor. Suppose for x minus 1 to be a factor also we have a shortcut. Suppose we have ax cube plus bx square plus cx plus d. This is the expression. For x minus 1 to be a factor of f of x, what is the shortcut is all the coefficients, sum of all the coefficients of all the powers, means a plus b plus c plus d. If sum of all the coefficients is 0, so then x plus 1, x minus 1 is a factor. Like that we can tell. Next children. So here we have example question, children. So find the remainder when 3x cube minus 5x square plus 3, 1. Here children, find the remainder when this expression is divided by x minus 2. So they have given one equation. Let us assume it is equal to f of x. F of x equal to 3x cube minus 5x square plus 3. If this f of x is divided by x minus 2, then the remainder is f of 2. According to remainder theorem, if f of x is divided by x minus a, then the remainder is f of a. So instead of x minus a, we have x minus 2 here. So instead of f of a, we can write f of 2. So f of 2 is the remainder. F of 2 we have to find it out. How to find f of 2? In the place of f of x, in the place of x, we have to keep 2 on the right hand side. Wherever we find x, there we have to replace x with 2. So 3 into 2 cube, 5 into 2 square plus 3. So 2 cube is 8. 3 into 8, which is equal to 24. 2 square means 4. 5 into 4, which is equal to 20 plus 3. So 24 plus 3, 27 minus 20 equal to 7. So 7 is the remainder. 7 is the remainder. So if this question is given as objective question, children, they may give options. What is the remainder? F of 2 is the remainder. F of minus 2 is the remainder. 7 is the remainder. Minus 7 is the remainder. Like that, they may give 4 options. In multi-correct answer type questions, they will give questions like this, and they may give 4 options. In this case, f of 2 is the remainder, A option is correct. 7 is the remainder, C option is correct. You can have 2 options. So in IIT means, what they will do means, they will, from the concepts, they will twist the questions and they will give questions like this. And they will give multi-correct questions like this, but you should not get confused. Next, another example, children. Find the value of k so that 2x cube minus kx square plus 3x minus 2 leaves a remainder 2 when divided by x minus 3. So they have given one expression, children. Let us assume it as f of x. And they have also given the clue that when divided by x minus 3, it leaves a remainder 2. It leaves a remainder 2. So according to remainder theorem, if f of x is divided by x minus 3, f of 3 is the remainder, which is equal to 2. F of 3 equal to 2 according to remainder theorem. Now we have to find the value of unknown value k, which is present in the expression f of x. So we have the clue f of 3 equal to 2, but f of 3 means in the right hand side of f of x, wherever we find x, there we have to keep 3. 2 into x cube means 2 into 3 cube, k into x square means k into 3 square, 3 into x means 3 into 3 minus 2. So 3 cube means 9, 9 2 times 18, sorry, 3 cube means 27, 27 2 times 54, 3 square means 9, 9 into k, 9k, 3 into 3, 3 into 3, 9, 9 minus 2, directly we can write 7. On the right hand side we have 2. Now children, 54 plus 7, how much? 61. It will come towards right hand side, it will become 2 minus 61. And left hand side only minus 9k will remain. So minus 9k, 2 minus 61, how much? Minus 59. So minus minus gets cancelled, k equal to 59 by 9. This is the value of unknown term given in the expression. K value 59 by 9. Next children, another illustration, children, another example. Let L1 and L2 be the remainders when the polynomials means expressions having many terms. Expressions having many terms are called polynomials. So L1 and L2 be the remainders when the polynomials, this is first polynomial and this is second polynomial, are divided by x plus 1 and x minus 2 respectively. Means first expression is divided by this first coefficient, second expression is divided by this second coefficient. During first time L1 is the remainder, during second time L2 is the remainder. So they have given, suppose if it is f of x they have given, if it is divided by x plus 1, then remainder is L1, that is one hint. Second expression, let it be g of x, if it is divided by x minus 2, then remainder is L2. That is the meaning of first sentence. And one more hint they have given, if 2L1 plus L2 equal to 6, then find the value of A. 2L1 plus L2 equal to 6. Find the value of A. So here, if f of x is divided by x plus 1, remainder is L1. But according to remainder theorem, the remainder is f of minus 1. F of minus 1, which is equal to L1. F of minus 1, which is equal to L1. And if g of x is divided by x minus 2, remainder is g of 2. Because this expression is defined in g, so we have to take g of 2, which is equal to L2. Which is equal to L2. So f of x they have given. So it is divided by x plus 1. So f of minus 1 is the remainder. In the place of x we have to keep minus 1. Minus 1 whole cube means minus 1 into minus 1 into minus 1. It will give minus 1 x square. 2 into minus 1 whole square. 2 into minus 1 whole square means 1, which is equal to 2. 5 into a into x means 5 into a into minus 1. But in the beginning we have minus 1. Minus into minus plus. 5 into a, 5a. Last term we have minus 7. After simplifying, minus 1 minus 7 minus 8 plus 2 minus 6 will come. Here 5a is there. So this can be written as 5a minus 6, which is equal to L1. Which is equal to L1. In the same way, g of x, if it is divided by x minus 2, remainder is g of 2. In the place of x, let's keep 2. And if we substitute all, we will get 4a minus 10, which is equal to L2. So we have got L2. So both L1 and L2 values we have got, but they have given another hint. 2L1 plus L2 equal to 6. In the place of L1, let's substitute value. In the place of L2, let's substitute value. 2 into 5a, 10a. 2 into 6, 12. 4a minus 10 equal to 6. 10a plus 4a, 14a. Minus 12 minus 10, minus 22 equal to 6. So minus 22 will come towards right hand side. It will become 6 plus 22, which is equal to 28. Now a equal to 28 by 14, which is equal to 2. Next children. Another example, children. Find the value of x so that x minus 1 is a factor of 2x square minus kx plus 2. It's a printing mistake, children. Please rectify this. Find the value of k here. Find the value of k so that x minus 1 is a factor of 2x square minus kx plus 2. Let us assume given expression as f of x. For f of x, x minus 1 is a factor. So according to remainder theorem, f of 1 is a factor. F of 1 is a factor. So if it is a factor means it completely divides. If they have not given just divided, if they give, if f of x is divided by x minus 1, there may be some remainder other than 0. But they have given factor, means which completely divides. Means remainder will be 0. Remainder will be 0. F of 1 equal to 0. How to find f of 1? In the place of x, we have to keep 1. 2 into 1 square minus k into 1 plus 2 equal to 0. 2 into 1 square is 2. 2 plus 2 will become 4. K into 1 minus k equal to 0. Minus k will go this side. We will get 4 equal to k, or k equal to 4 we can write. So this is about remainder theorem and some example children. So remaining problems we can learn in our next videos. So thank you for watching our video children. Please subscribe our channel and press the bell icon for receiving the latest updates. You can also visit our website children, aimstoday.in, for information regarding other online classes, quizzes, worksheets, activities, English classes, coding skills, Vedic maths, and so many other things. Thank you children. Have a good day.